Scientists have attained knowledge which has allowed humanity to do what seems to be impossible in the realm of possibilities, but we deem them as normal because of how far humanity has come in the great name of science. One of the great developments in science was made in the late 1940s by a man who goes by the name of William Libby when he invented one of the most used and accurate dating techniques known to man today. We have managed to determine the age of many things, from dead bodies to dinosaur fossils, but how exactly do scientists do this? It all starts with isotopes. Isotopes are forms of a chemical element with atoms of the same number of protons but different number of neutrons. This alone is not enough to determine the age of anything though. In order to do so, we need to dive deeper and look at the specific isotope. This isotope is rare but naturally occurring. We call this isotope carbon-14. Carbon-14 has a half-life of 5,730 years, meaning that after 5,730 years, only half of the original amount of the carbon-14 remains in a sample of organic material. Carbon-14 is made due to cosmic ray bombardment, which is collisions between cosmic rays and nitrogen in the Earth's atmosphere. These rays knock off the protons in the nitrogen, turning it from nitrogen-14 to carbon-14. Carbon-14 then combines with oxygen and creates carbon dioxide, which is then absorbed by the trees and the plants, and finally animals eat these trees and plants, thus incorporating carbon-14. What makes carbon-14 special is that it is a universal constant in all living organisms because it is made at the same rate as it decays. However, when an organism dies, the amount of carbon-14 remaining begins to decrease at a constant rate. But why exactly is this important, and how does this allow us to determine the age of an organic material? The fact that carbon is a constant and that it begins to decrease is exactly what makes it special, because it allows you to measure the remaining carbon-14, and in doing so, you have measured the age of that specific organism. We call this carbon dating, a way of determining the age of an artifact or a sample of organic material by measuring the remaining carbon-14 it contains. In doing so, scientists are able to calculate when a specific organism has died. Still, no matter how great this might sound, carbon dating has its limitations. Samples that are older than about 40,000 years old are extremely difficult to date. Due to tiny levels of carbon-14, and samples over 60,000 years old cannot be dated at all. Nevertheless, even with these disadvantages, this has still taught us more about ourselves and the world we inhabit.